Lesson 2-11, ratios of fractions and their unit rates. During their last workout, Izzy ran 2 1/4 miles in 15 minutes, and her friend Julia ran 3 3/4 miles in 25 minutes. Each girl thought she was the faster runner. Well, one ran 2 1/4 miles in 15 minutes. Julia ran 3 3/4 miles in 25 minutes. So we don't have the same distance and we don't have the same time. Based on their last run, which girl is correct? Use any approach to find the solution. Number lines, which I'm going to do. Bar models, I'm not going to do. Table, yes, I'm going to do a table. Equation, and a clock. So I've already filled in some of this for you to save time. Fill it in along with me. So we have your lesson 211 notes out. So Izzy, she's running 2 1/4 miles every 15 minutes. 15 minutes is 1/4 of an hour. I'm going to change it to hours. 30 minutes is a half of an hour. 45 minutes is 3/4 of an hour. 60 minutes we know is 1 hour. And 75 minutes is 1 1/4 of an hour. I'm going to change all of their time, since they're different minutes, into parts of an hour. I think that's going to help. In 1/4 of an hour, Izzy ran 2 1/4 miles. In 30 minutes, doubling that, she would run 4 1/2 miles. In 45 minutes, or 3/4 of an hour, she will run 6 3/4 miles. In an hour, she runs 9 miles. In an hour and 15 minutes, or 75 minutes, or an hour and 1/4, she runs 11 1/4 miles. So I've got the table started. Let's see if any of those things come up on Julia's time. So let's put Julia in time in parts of an hour. Well, 25 minutes is 5/12 of an hour, right? Because here's the clock. Then you hit the 5 out of the 12 parts. That would be 25 minutes. So that's where that 5/12 is coming up from. 25 minutes out of 60 does reduce to 5/12. 50 minutes, 50 out of 60, reduces to 5/6 of an hour. So far our time is not the same yet. 75 minutes, oh, that's 1 1/4 hours. Hey, we've got 1 1/4 hours on Izzy. And 100 minutes, that's an hour and 2/3 of a minute. Or 2/3 of an hour and 2/3 of an hour. So we have a similar time here. 75 minutes. Counting by 15s and counting by 25s, we're going to get a similar time in minutes and a similar time in hours. The distance that Julia runs in 25 minutes is 3 3/4 miles. Doubling that, in 50 minutes, she would run 7 1/2 miles. In 75 minutes, she runs 11 1/4 miles. That's exactly the same. That's exactly the same. Same distance. Same distance. Oh, they're running exactly the same. This table is proving it. In 75 minutes, 1 1/4 hours, they're both running 11 1/4 miles. Just to fill this in, if Izzy runs for 100 minutes, she's running 15 miles. So they have the exact same, they're going to tie. They tie. Using any approach based on their last run, which girl is correct? They think that they're, based on their last run, which girl is correct? Each girl thought she was the faster running. They're both wrong. They tied. In this next block, I'm going to use y = kx. I'm going to use my equation, y equals kx. So if 4.5 hours or 4.5 miles is equal to my k times my half, my x being a half of an hour, if I divide by 1/2 or multiply by the multiplicative inverse on both sides, if I want to get their rate, I want to find their rate, I could do y equals kx, or I could do y divided by x equals k, which I think I'm going to switch this. I'm going to do, no, I'm not using that. I'm going to do y, oh, come on, pen. Y divided by x equaling k. I'm going to find their rate. So, my y, and I can pick any one of these points up here, and I'm picking the point 4.5 and 1/2. I'm picking this point for Izzy. This is Izzy. The left side is Izzy. So in 4.5 miles, it took her a half hour to get there. 4.5 divided by a half is the same thing as 4.5 times 2, which equals 9 miles per hour. That's Izzy's rate. She's traveling at 9 miles per hour. Julia, okay, I can pick any point on her table that I have, and I'm going to pick after 50 minutes for her. So she's gone y divided by x equaling k. Her 7.5 miles in 5/6 of an hour. Well, that's the same thing as 7.5, which is 15 halves, times, multiplying by the multiplicative inverse, 6 fifths. And that also equals 9 miles per hour. They're running at the exact same rate. So their rate is the same, their unit rate, their K. Their Ks are equal. K equals 9 miles per hour. K equals 9 miles per hour. They're running at the same rate. So again, they're going to tie. The clock idea, okay, Izzy runs 2.25 miles in 1/4 of an hour. So if I multiply, and she runs, here's 1/4 of an hour, which is, 15 minutes, and then 30 minutes. She runs another 2.25. Then she runs another 2.25 miles in another 15 minutes, right? 45. And then in the hour, she runs another 2.25 miles. So altogether, 2.25 times her 4 quarters, every 15 minutes is 1/4 of an hour. Yes, I can figure her rate using a clock. She's running 9 miles per hour. Now, Julia's a little different. She's running in 25 minutes. So in 25 minutes, she's running 3.75 of an hour. So here's my hand pointing down to the 5. That's 25 minutes. Well, 25 more minutes after that would get me up here to 50, which would be pointing at the 10 now. That's another 3.75 of a mile. And then she has another 10 minutes to go, or 5 minutes here. So this 5 minutes to get to the 11, and then 5 minutes to get to the 12. Well, she's running 3/4 of a mile in 5 minutes. Because if I take 3.75 in 25 minutes, if I want to know what is this in 5 minutes, dividing by 5, divide this by 5, I get just the 3/4 left. So she's got 3/4 of a mile here and 3/4 of a mile here. And if I add that all up, 3.75, this one, plus this 3.75, plus this 3/4 of a mile, plus this 3/4 of a mile, guess what? I get 9 miles in that 1 hour. So she's running at a rate of 9 miles per hour. The same constant unit rate. I could do it using a clock. And the last way that I'm going to compare their time is using two number lines. The top number line, as you can see, is the miles, and the bottom number line is the time. And they're equally spread exactly apart. And Izzy, as you can see, she runs in 15 minutes, she runs 2 1/4. So again, in that 75 minutes, she's going to run 11 1/4 hours. That's the same on this number line. And here I can see actually Izzy's rate that she's running 9 miles per hour. I don't see 9 miles per hour on Julia's time, but I do see at 75 minutes she's run 11 1/4 miles. So I know they are running at the same rate, because after 75 minutes they're going to be exactly 11 1/4 miles at the same point in the race. So different ways to compare ratios and fractions and unit rates. The unit rate here, both girls are running at 9 miles per hour. Pretty cool way of seeing it. The next example. A turtle walks at 7/8 of a mile in 50 minutes. What is the unit rate expressed in miles per hour? Well, to find the turtle's unit rate, Meredith wrote and simplified the following complex fraction. Explain how the fraction 5/6 was obtained. Well, 50 minutes out of 60 minutes, what part of an hour is that? I did that in the last problem. That's 5/6 of an hour. So if you take the miles, 7/8, per the hour, if I divide 7/8 by 5/6, this is a very unique way that Meredith did this. This is not how I normally would do this. I'm going to come back to this method that she did here. And I'll show you I'm going to get this same answer. I'm going to do 7/8 divided by 5/6. The traditional way that you would do it would be, okay, 7/8 divided by 5/6. Well, we learned, keep the first fraction, change it to multiplying by the multiplicative inverse. So multiplying by 6/5, well, 6 and 8 do have a 2 in common. So 8 divided by 2 is 4, and 6 divided by 2 is 3. So when I multiply that, 7 times 3 is 21, and 4 times 5 is 20. So she's clearing the bottom by multiplying both parts of it by 24 over 24. She's really just multiplying by 1, right? So 6 goes into 24 4 times, carries the 1 over here, and 8 goes into 24 this 3 times. So now she has 7 times 3, which is 21, and 5 times 4, which is 20. Did Meredith simplify the complex fraction correctly? Yes. Instead of multiplying by the multiplicative inverse 6/5, she multiplied the fraction by 24 over 24, which that just equals 1. She hasn't changed the value of this fraction, but she definitely changed the look of the fraction. 7/8 divided by 5/6 is 21/20. So she does not change the value of the problem. Did you know you could divide like that? I bet you didn't know that. Another way you could divide fractions is by multiplying by their common denominator. It's a very cool way of doing it. Number 2 here. For Anthony's birthday, his mother is making cupcakes for 12 of his friends at his daycare. This recipe calls for 3 1/3 cups of flour. This recipe makes 2 1/2 dozen cookies. Anthony's mother has only 1 cup of flour. Uh-oh. Is there enough flour for each of his friends to get a cupcake? Well, it needs 3 1/3 cups of flour to make 2 1/2 dozen cookies. Well, Mom doesn't have 3 1/3 cups. She only has 1. cup of flour. So, to make 1 dozen cookies, I want this to be a dozen cookies. Why a dozen? Because he has 12 friends. So if I just find the unit rate, how many cups of flour per 1 dozen? If I actually divide the y by the x, I'm going to get the cups of flour per 1 dozen cookies. So I'm not going to figure out the 1 cup of flour. I'm going to figure out the 1 dozen cookies. So I'm going to take 3 1/3 and divide it by 2 1/2. Hopefully you remember that you cannot divide mixed numbers. You have to change that to an improper fraction. So 3 1/3, remember this little trick? 3 times 3 gives you 9 plus the 1. So you multiply, add the 1. That's 10/3. How to change a mixed number to an improper fraction. Divided by, so 10/3 divided by, well, 2 1/2, using that same idea. 2 times 2 is 4 plus 1 makes 5 halves. 10/3 divided by 5 halves. Oh, I could use that Meredith trick. But I'm going to do 10/3 times, keep it, change it, flip it, 2/5. Does anything cross cancel? Yes, the 5 goes into 5 once, goes into 10 twice. So I get 4/3. She needs 1 1/3 cups of flour to make 1 dozen cookies. Can she do it? No. She only has 1 cup of flour. So can Meredith's mom, does she have enough flour? No. She does not have enough flour. So I'll make sure we're answering the question. She does not have enough flour. Nope. She can't make the dozen cookies. Someone at the daycare is not going to get one, so probably shouldn't make them. Next question. Sally is making a painting for which she is mixing red paint and blue paint. Red paint and blue paint. The table shows the different mixtures being used. With 1 1/2 quarts of red paint, you put 2 1/2 quarts of blue paint. With 2 2/5, you put 4. With 3 3/4, you put 6 1/4. What are the unit rates for the values? Oh, and then we even have decimals in here. Well, I'm going to call this the y, and I'm going to call this the x. So I need to find what is the unit rate. Is this the same unit rate with all of these values? Well, let's see. 2 1/2 is 5 halves. Divided by 1 1/2 is 3 halves. So I get 5 halves times 2/3. Well, these 2's cancel and I get 5/3, which equals, and I'm going to change it to a decimal for a reason, because I have some decimals down here as well. So I could leave it the fraction 5/3 or 1, and yes, that's a repeating 6/10, repetant 6/10. 4 divided by 2 2/5, well, that's 4 over 1. Divided by 2 2/5 is this 12/5. So 4 over 1 times 5/12. Well, those cancel. And I get that 5/3. Well, that's looking good so far. Same rate of mixture of blue paint to red paint. Notice I'm doing blue paint to red paint. And yes, I did do all of these. So 6 1/4 divided by 3 3/4 is the same thing as 25 quarters. This is 25 fourths. And 3 3/4, because I'm running out of room over there, is the same thing as 15 fourths. So keep it, change it, flip it. Times 4/15. The 4's cancel. 15 and 25 have a 5 in common. So yes, I'm getting 5/3, which is 1 6/10 repetant. 6 2/3 divided by 4, I'll leave that one for you to do. Let's go to 2 divided by 1 2/10. Taking out my handy dandy calculator, I get 1 6 repetent. Looking pretty good here. 3 divided by 1 8/10. And yes, I get 1 6 repetent. So the mixture, what is the unit rate? 1 2/3 quarts of blue for every, I did blue to red. So I'm doing blue, I divided blue by red. Blue to red, that's my unit rate. So I've got 1 2/3, because 0.6 repetent is the same thing as 1 2/3. Or I could say 5/3 blue paint to per 1 quart of, oh, I should say quart here, 5/3 quarts of blue paint, quarts, to 1 quart of red paint. I want to have my labels on there. So 1 or you could say 1 2/3 if you don't like that. Or you could say 1.6 repetent. They all mean the same thing. Quarts of blue paint to 1 quart of red paint. That is the unit rate. Is the amount of blue paint proportional to the amount of red paint? Yes. There is a constant unit rate. It happens to be 1 2/3 or that 1.6 repetent. Same thing as 1 2/3, same thing as 5/3. There is a constant unit rate on all of those. Describe in words what the unit rate means in the context of this problem. Okay, well, for every 1 2/3 quarts of blue paint, who is this? Sally is mixing 1 quart of red paint. That's what it means in the context of this problem. Blue paint to red paint. That's the order that I did. So that's it for today. Some good practice of mixed numbers and fractions.